Yes, welcome back to the session. In this video, I'm going to discuss about electric potential due to multiple charges. Okay, so basically it states that the net potential at any point is equal to the algebraic sum of their individual potentials at that point. Okay, so first of all I will draw the diagram and then I will go to the derivation part. Okay, it is very simple topic. Let's say for example I have n number of charges. The first charge is q1, second charge is q2, third charge is q3, and so on, nth charge is qn. Okay, so I'm going to calculate electric potential at a particular point due to this n number of charges. Am I right? Let's say for example that particular point is I'm taking somewhere. Let us assume this is point P. Okay, now what I'm doing here, I'm connecting a line from charge q1 to point P, and this distance of separation is r1. Okay, similarly charge q2 to a same point P, the distance of separation is r2. Similarly from charge q3 to point P, this distance of separation is r3. Similarly the distance from point P to charge qn is Rn. Okay, so I'm going to calculate multiple potentials, right? So the first, what I'm going to write here, electric potential at P due to charge q1 is V1, which is equal to 1 by 4 pi epsilon naught into Q1 by R1. Okay, similarly, electric potential at P due to charge Q2 is V2 is equal to 1 by 4 pi epsilon naught into Q2 by R2, and so on. Like that, electric potential at point P due to nth charge is Vn is equal to 1 by 4 pi epsilon naught into Qn by Rn. Okay, so these are the n number of potentials which are acting exactly at point P, right? So based on this, what I'm going to do here, the net potential according to superposition principle, net potential is equal to algebraic sum of V1 plus V2 plus and so on plus Vn, right? So V1 formula we know, V2 we know, and so on, Vn we know. So these formulas I'm going to substitute here. So V1 means 1 by 4 pi epsilon naught into Q1 by R1 plus 1 by 4 pi epsilon naught into Q2 by R2 plus and so on 1 by 4 pi epsilon naught into Qn by Rn. So look at this equation carefully. 1 by 4 pi epsilon naught is the common term, right? So take it separately. So therefore 1 by 4 pi epsilon naught into Q1 by R1 plus Q2 by R2 plus and so on Qn by Rn. So this is the net potential at point P. Okay, so I hope you understand. Thank you so much.